Hello to everyone from all around the world. First of all, thank you very much for taking the time and joining this webinar. We're going to do our best to make sure that you get value out of this session and also the topic that we're going to cover, which is migration without misery. And it's really all about cloud to cloud migrations, which are growing in scale and size all around the world. My name is Arshad Syed. I'm the Chief Business Officer and a co-founder of StackGen. And I'm joined with my fantastic colleague, Arunav. Arunav, you want to introduce yourself?
Yep. Hey, everyone. My name is Arunav. Thanks for joining in. I've been doing solutions engineering and working in DevOps probably around 5 years. And a lot of the time has frankly been centered around cloud migrations, right? How do we migrate when we're doing CI/CD? How do we move processes? What kind of tech stack should we start moving into? A lot of these things. So this topic is pretty near and dear to my heart. So very excited to dive into a few examples of how to do it, what not to do, and et cetera.
Thanks a lot, Arunav. And I do want to start by saying thank you, Maria, for being our host and helping us coordinate and orchestrate this session. Please keep your questions coming on the Q&A and the chat window. You have 2 of them, so you can use the Q&A window as well. What we're going to do over the next probably 25 to 30 minutes is really talk about our live experiences with customers around cloud-to-cloud migrations and really sort of look at it from that lens, from a practitioner's lens. Both me and Arunav are in front of customers. We are doing a number of cloud migrations across different public clouds. And also to define a little bit the boundary conditions, we are really focused here around public cloud to public cloud migrations. And that's really what we're going to deep dive into technically. And you can ask us any questions. We'll try and answer them as much as possible today, or we could also take it up offline after the call is over. But remember, we're going to pick the best question, and you're going to get a fantastic award to join PlatformCon Live in New York City. So let's start with the topic around cloud-to-cloud migrations. And why is that? Why are people looking at cloud-to-cloud? And what is the preeminent conditions that you require from a successful cloud-to-cloud migration? In fact, today, if you look at the Gartner data, almost 81% of the enterprises have more than 2 cloud providers in their environment. And this is across small to medium to large enterprises. And this trend is only accelerating because I think we're in a world where there is a massive wallet share battle going on between the cloud service providers. And with the advent of more and more AI workloads coming in and AI models proliferating across multiple cloud service providers, by evolution, more and more enterprises are going to have more and more clouds. And when that happens, enterprises and businesses are going to be left with the question of, how do I move my application seamlessly across these clouds? How do I move my data models across these clouds? When do I and how do I make the best choice from an optionality perspective, which applications go to which cloud? And if I do want to make a choice and move that application, what's the process? How does it look like? And how easy or difficult that is? The other thing that's really starting to emerge is cloud price points are dropping very fast. That's just, essentially a combination of Moore's law and also the economies of scale that are kicking in. For the longest time, AWS was, and to some extent continues to be, the leader in the cloud space. But now there are so many more cloud providers that are now evolved and emerging on the marketplace across all the tranches of the enterprise segment. In fact, we find with our clients that they are actually making choices around their environments, around their workloads, and their cloud providers, and availing of the opportunity to use multiple cloud service providers. And the decision points sometimes are based on, if it's a lower environment, why do I need to spend so much of money with a large cloud service provider with bells and whistles? If it's more of internal workloads, why can't we actually have it on a cloud service provider that gives you different optionalities, different feature sets that are more suitable for those kinds of workloads? And for AI workloads, it could be a different service provider. Clients are also realizing, and the clients that we are working with specifically, when we ask them, why are you actually, this is more of a work, this requires a lot more planning, a lot more effort. Clients also want to make sure that they do not get locked into a particular cloud service provider for long periods of time. Because as we all know, we are all dealing with cloud sprawl. We are dealing with FinOps. More finance pressure is coming in terms of reducing the cost structure in the cloud as well. And there are some cloud providers who are now quoting 40, 50, 60% lower price points than some of the largest cloud service providers for similar kind of functionality. So I think there are a convergence of multiple trends that are driving enterprises to actually choose multiple cloud service providers. But then the question becomes is how do you be nimble? How do you become nimble enough to move your enterprise workloads across different clouds? So Aruna, if you could go to the next slide, please. Now, migrations across clouds to some extent do have some impediments. Now, these impediments are going away, but there are definitely some level of deep thinking that you need to do as you think about cloud to cloud migrations. First and foremost, most of these cloud service providers have built ecosystems that are closed ecosystems, proprietary to a good degree. But I think as more and more different database providers, different platform providers are launching on these platforms, that ecosystem is not as close as it used to be a few years ago. And I think that trend is going to continue. We're going to see more and more of these ecosystems being proliferated by third-party tools, databases, queuing systems, notification systems, etc., so that you can actually now use the same provider across multiple cloud environments, right? But having said that, the resources and attributes are definitely distinct. And as you build, and most enterprises have built their evolution into cloud, into one service provider, elements like the attributes, the variables, the way the architecture has been built needs to be a point of consideration when you're moving from one cloud to the other cloud. The second thing is, we all know we build applications over a period of time. We build a lot of custom interfaces, APIs, services that we may just evolve naturally with our comfort zone into one cloud service provider. When you're migrating the application, you got to think about how are you going to migrate all of that as much as possible seamlessly to another cloud, and keep that as discrete as possible so that you have the ability and the agility and the nimbleness to do that with the least amount of time, the least amount of effort, and the least amount of pain. The other element that we see clients run into, in fact, this is a common element, is the IAM policies are key to migrate, because you want to make sure that all of your privileges, all of your identity access management is also as close to the source cloud you can keep, because you do not want to drive any kind of disruption when you move from one cloud to the other cloud. This is one of the elements that sometimes gets overlooked when you're migrating from cloud to cloud. And associated with that are the risk, compliance, security, and governance policies. I'll give you a simple example. We are working with a few of our clients, and over the years, they have built some custom policy environments and custom policies that they want to enforce in their enterprise workloads. Now they are migrating from one public cloud provider to the other public cloud provider. They want to be able to migrate all of those custom policies and their current other policy postures. It could be things like NIST, it could be PII, it could be PCI, it could be GDPR. They want to make sure that the amount of effort and intelligence that they have built and they have taken time to build around the particular application, all of those also comply and move, and they are not starting from scratch again. Finally, we all build integrations across accounts. It could be across services, across applications. We want to make sure that all of them are able to translate and migrate from one cloud to the other cloud as well. Now, a couple of things in our experience, what we also find is the cloud service providers handle certain elements or resources very differently from each other. For example, the way Azure handles storage accounts is very different and distinct from how AWS handles it. And I can give you more examples, and Aruna probably might go through certain specific examples as well. In our migration experience, having done this a few times, we realize that those are elements that have to be kept in mind and have to be thought through in terms of what decision points are you going to be reflecting on when you move from one cloud to the other cloud. So that those are some of the impediments to think about. Having said that, I think it's becoming more simpler to migrate from cloud to cloud, provided you have the right enablement, the right tools and the technologies on your side. So if you could go to the next slide, I don't know. I'm not going to really focus and spend too much on time because planning cloud to cloud migration is a very involved exercise. This is too simplistic a slide to cover every element of it, because you need to plan for the infrastructure layer migration, the application infrastructure migration, the data migration. And many enterprises and businesses today take the opportunity sometimes to take 20% of their applications, re-engineer them, because they feel like this is the right opportunity and the time to rethink their application strategy as well when they are moving from one cloud to the other cloud. What we are going to really focus on, and by the way, the final thing before I forget, is change management as well, because the developers might be used to a particular cloud provider. Now they got to sort of acclimatize, understand, and be able to work with your pipelines, with your IAC onto the new cloud. And the users would also need to, if there is any kind of change management you need to do with the end users, hopefully there is not much, they don't see anything, it's transparent to them. But change management aspects, communication aspects have to be thought through as well when you move from one cloud to the other cloud. Having said that, I don't know if you could go to the next slide, please. Thank you. Cloud to cloud migration is not as difficult and painful as it used to be a few years ago. And as you are thinking about cloud to cloud migration, you all are here. I'm sure at some point in time, you're going to run into this. This is becoming a more common phenomena. And as cloud becomes more commodity, we're going to see more and more cloud migrations. A few things to keep in mind. One is having a robust tool, and a little bit of a plug here for StackGen, a platform like StackGen that automates a large part of that migration at the application layer would be a key to success, because so that you don't have to sit down and do this manually from one cloud to the other cloud. Some data points for you. We have spoken and we are working with large clients that are doing very large migrations from one cloud to the other cloud. What we find is, in the absence of a tool, you're going to be doing manual mapping of resources, of attributes, of variables, of policies, and that could take weeks or months. In fact, with one of our clients, their initial estimate to do application migration just for one moderately complex application, just the mapping itself was going to be weeks in terms of the time elapsed and the effort that was going to take, because they had to do everything manually. Not to mention that in many times the source cloud expertise exists, but the destination cloud expertise does not exist with the team that's trying to make this migration. They have to learn about the new cloud. They have to understand the new cloud. They have to understand the nuances of how the services or the APIs or the resources and the treatment of the attributes and dependencies changes from one cloud to the other cloud. So having a tool definitely is a very important element of it. The second thing that we have heard and we have seen in live environments is most of us, most clients, businesses, do not have a robust footprint, you could call a bill of materials, or a comprehensive control of every single resource in their runtime cloud. So how do you make sure that when you're migrating, you're actually doing a very tight migration at the deepest level? So having the ability to scan the runtime cloud, reverse engineer, and then create the target cloud is a very important capability that you need to look for when you go out there and look for a tool that gives you that ability to migrate from one cloud to the other. Doing it manually leads to significant errors and misses across the board. What we have found working with clients is when we do this in an automated manner, we actually find quite a few good surprises for them where they're able to optimize their costs. Sometimes they are able to see their exposures. They're able to figure out they have a lot of resources that probably they needed to optimize anyway. So this exercise done with the assistance of a tool in a robust manner can actually throw up a lot of positives. But having an understanding of the runtime cloud, of the source cloud, is very essential so that you do not have problems and you do not have to iterate back and forth to make sure your target cloud is very close, if not exactly similar, to the source cloud. The other thing is, as I said earlier, is the migration of your cloud security posture, your governance, compliance, security policies, having a rules engine that allows you to apply these right when you're in the midst of the migration on the target cloud and having it replicate what you have in the source cloud is extremely important. Otherwise, you're going to spend a significant chunk of time recreating potentially all of that and maybe missing that in the process if you're trying to do that manually as well. So that's another area we have found is important to focus and make sure that you're able to migrate through an automated manner. Now, one thing I will say, a big part of the migration is the data migration, which is something I'm sure we'll all deal with, and that's a whole new topic and a big topic to talk about. And then finally, change management as well. But just even moving the application architecture and infrastructure from one cloud to the other cloud can be done in days. You don't have to take these days months. We have had clients we are engaged with where they have had experiences in the past. It took them 9 to 10 months to move a few application workloads. And in the manual process, they went through a lot of pain trying to migrate from one cloud to the other cloud. And the decision came in from the top. The decision was the right decision. It was made for the right reasons, but the process itself was very tedious and painful. So with that, I'm going to pass it to Arunav, who's going to now go deeper in terms of how to think about these cloud migrations and maybe take you through some very live examples of what are the issues you need to think about when you're doing this. So with that, Arunav, over to you.
Alrighty. So, I think if we distill down everything that Archer just covered, right? Migrating to a new cloud typically ranges from a tedious experience to quite often a miserable experience. All right. And what I'm going to do is I'm going to go over just two of what I think are some of the most miserable parts if done wrong. Okay. So the first I want to cover is unnecessary lift and shift. All right. So we're all familiar with lift and shift as a strategy, right? It's whatever application architecture that we are running from our source cloud, let's just move it over exactly the way it is and just use whatever one-to-one cloud service equivalents exist in our destination, right? This is great because it theoretically requires no to minimal refactoring, and it usually happens especially when we have timeline pressure, right? We need to migrate to XYZ cloud, and we have to get the whole thing done within 12 months, right? A lot of lift and shift starts happening around month 9 and 10, right? So lifting and shifting is a, often it's a go-to strategy, but if done wrong, it can really defeat the entire purpose of migrating, right? Sometimes like cloud migrations, they're done for data sovereignty reasons and security when it comes to like regionalization. But a lot of times cloud migrations are done just for cost control, right? Something is cheaper to run in a different cloud. Let's move everything over. A bad lift and shift can really unoptimize the cost of running our workloads to the point where after a few years, we realize the migration wasn't even really that worth it. Okay. The situations where it is good is it's great for cloud agnostic platforms, right? So for example, Kubernetes running open source databases or caches, like Redis, for example, those kind of platforms will be relatively easy to migrate. But it's not really so great in other scenarios, right? Like when we get out of the realm of like object storage and like relational DB and like K8s or even VMs, like that's when things get tricky. Okay. So what I'm going to get into is a few scenarios on how we do lift and shift. All right. So here, what we're looking at is an application architecture where we have a Kubernetes cluster running on EKS. Within this cluster, we're running Backstage, a few other applications. That part doesn't matter. And within this cluster, right, we are loading in secrets from AWS Secrets Manager, right? We are pulling in container images from ECR. Certs are getting handled at the load balancer level, and we have Amazon Route 53 setting up our DNS and routing tables for us. Okay, the cluster itself is only really dependent on a external DB service that's running on Amazon RDS, where we have PostgreSQL. Okay. If we have to look at this application and decide whether a lift and shift is good, right? What we can do is we can go through and look at each of these pieces and figure out, okay, which of these pieces have a one-to-one equivalent, and is there any issue moving it into an equivalent without refactoring, right? So right off the bat, if we start out with the outermost options, if you look at, say, Route 53, Cert Manager, AWS Secret Manager, and then Amazon ECR. These services themselves are not doing anything special when you look at different cloud providers to add value, right? The real value is what is stored within them, right? You only care about the images inside ECR and the secrets inside the secret manager, same with the certs, right? These are very easy to port over into new clouds typically, because you just have to set up some access controls, which are not going to be that difficult. And really you're just migrating all your data into these, okay? After that, if we look inside the cluster itself, typically when we're going from EKS into something like GKE, that migration is very often like one of the most easiest parts to migrate. Going from EKS to GKE is a little bit easier, in my opinion, because GKE is a more opinionated managed Kubernetes platform. So it's easy to go from a less opinionated one like EKS into GKE, where it'll start setting up automatically for you all the logging, the monitoring. You'd actually have to, you don't have to do too much. The things just kind of automatically get set up for you. Okay. And then Amazon RDS, if it's running Postgres, this is like a very easy lift and shift target, right? Like going from RDS to something like Google's Cloud SQL in most cases is like a very nice and easy transition, right? Like we can set up a equivalent Postgres DB engine in Cloud SQL, set it up with ongoing replication from this source RDS instance, and once that DB synchronized and then we have that continuous synchronization going, at that point we can launch our GKE cluster, right? Deploy our Helm charts, operators, what have you, onto the cluster, point it to Google's Cloud SQL, and then we'll basically be good, right? Maybe there are a few stateful apps exist where we're gonna run into issues, but for the most part, this is gonna be a pretty smooth transition. All right, so this is an example of where lift and shift makes total sense, okay? Now, let's get into a second scenario, right? And this scenario, we are looking at a different application architecture. Think of this as like a poor man's business intelligence tool, where we basically give some users access into Amazon Athena so that we can query out using SQL some data from a DynamoDB table. Okay. In this example, there's going to be a whole bunch of issues when we try to look at what the equivalent would look like inside GCP. All right. So the good news here is that at least Amazon S3 converts very nicely into GCS buckets, right? So that's always fantastic. But then it just starts going downhill from there, right? Amazon Athena does not have a direct equivalent inside GCP, right? So if you look at Athena, Athena's a serverless like pay per query SQL engine, right? That can just be hooked up to basically any data source, right? And they even have a native connection in from Athena into DynamoDB using Lambda functions. All right, so this makes this use case, right, of like BI querying, like BI querying systems, like relatively easy to get up and running with Athena, and it really stops you from having to set up complex ETL pipelines or data replication jobs to get that same job done. All right, but if we wanted to port this into GCP, it would require heavy workarounds, or it would take big performance and cost impacts, right? So for example, if you look at like the closest equivalent to Athena inside GCP, like most people would probably say BigQuery, right? Now, BigQuery is not exactly the same though, right? BigQuery is like a data warehouse, and that operates on structured data and doesn't support querying NoSQL databases, right? And if we're now looking to port over, everything from Athena into BigQuery, like one of the things that we're going to be dealing with is all of the queries are going to be significantly slower, okay? Because BigQuery is optimized for data analytics. It's going to have very fast analytics, which are like larger, more complex queries. But for quick lookups, like which in this use case, our users trying to get some, I guess, product usage or growth metrics quickly extracted, right? Those I guess transactions are going to take way longer than they would within Athena plus DynamoDB, right? DynamoDB is optimized for like millisecond response times when you're looking up data. We're not going to be able to get that when we're hooking up BigQuery to, Fire. When we're hooking up BigQuery to like any equivalent DB system inside GCP. Okay, so some other issues are when we look at the GCP setup, right? There's no built-in data source connector, right? Here we got very lucky because Amazon has a nice Lambda connector interface that hooks up Athena to DynamoDB. If we're trying to set up like like Firestore or Bigtable as like the NoSQL database, we're gonna have to cook up our own connector, right? Like, and often what that's gonna mean is we're gonna have to figure out a way to replicate that Lambda function into maybe a Google Cloud function, and that's gonna take a little bit of refactoring to set up, and it won't be a native experience, right? It's gonna take some of our team's time to actually build this out ourselves. Okay, so really, like this starts opening up a lot of questions, right? What are we actually going to be migrating something like DynamoDB into, right? Like, should this go into BigQuery? Should it go into Firestore or Bigtable? Each of these have slightly different pros and cons, where depending on like the nature of the query and like the nature of the data that's getting extracted, we might need to think. Well, not might. We definitely need to think very hard about which database target we're going to be migrating our DynamoDB into. Okay. So what's the solution to this? Frankly, the best solution here is don't migrate. All right. And this is an option that I think a lot of times folks just don't think about, right? Because a lot of times we're just told from leadership, hey, we have to migrate, right? But this all goes back to defining what is our multi-cloud strategy. Are we okay going multi-cloud, or are we forced to do a cloud cutover, right? Because this is one of the main benefits of the multi-cloud approach. Not everything has to move, right? Some application architectures are just natively designed better, like in the case that I just showed you, to run in one cloud compared to moving it into another cloud, right? And in this case, we could get it done to move it to the other cloud system, but it's frankly just going to take a lot of rework to get it working, and none of that rework is actually going to be providing any business value. It's not like we're improving the application or improving the application architecture. We're just trying to make it do what it used to do, right? So That's one of the big things. Like wherever possible, like really figure out which applications are worth keeping on the source cloud, because not everything has to move, right? Now, if forced to migrate, which a lot of times we are, right? This is an example of an application that should probably be deprioritized, right? There's a lot of low-hanging fruit that can be migrated very quickly. For example, that EKS plus RDS application architecture, that's going to be a quick win, right? Those are very easy to move into Google, and we're going to be able to show like rapid adoption for any of our workloads that have to, that fall under that architecture pattern. And in terms of just, getting off for cost reasons, even the faster we get, those relatively expensive workloads into the target cloud, right, the better. Okay, this kind of workload with Athena and Dynamo, right? This is probably something that I would take up last, right? Because it's just going to be like just tech debt refactoring. There's going to be no real benefit, and there might not even be that heavy cost savings, if at all, when we move it to Google. So in this case, it's better to just rack up quick wins. Okay. Now let's get into the second source of misery, right? And at a high level, I couldn't think of a more eloquent way to say this, but it's just temporary designs that end up becoming permanent. Okay, and I think a lot of folks who joined in, if you guys have done a cloud migration, you've probably seen this, right? So some examples of temporary designs are, we're migrating clouds, and we're going to just over provision the clusters and whatever compute resources we have, right? Because migrating already is going to take a long time. We don't want to deal with performance issues, right? We're going to give overly permissive IAM roles or principal roles, right? Because we aren't familiar with this new destination cloud, and we just don't want to be troubleshooting IAM. We'd rather just get the application working, right? Giving dev teams access to the cloud console, right? This, you often have to do this just because dev teams don't really know what's going on, right? And if we dig into the underlying issues behind these temporary designs, right? Devs are not going to want to deal with performance issues when they're going through a migration. Devs are going to want to move fast, right? And moving fast is the opposite of troubleshooting IAM roles and permissions issues, right? And devs need a UI to understand this new cloud system that they're setting up and having to migrate into, right? And they need this UI from the console, frankly, because devs don't know or just don't really care to know something like Terraform, right? Which is a way that you can help define it through code. Okay, and if you're seeing a common theme to the underlying issues behind these temporary designs becoming permanent, it's not devs, it's dev experience. Okay, so this is not the developer's fault, right? This is a developer experience problem, and bad developer experience breeds bad behavior. All right. If we look at why devs ask for cloud console access, right? This is something that always happens, right? And it's always given just because it's going to make life easier for the devs, right? All of a sudden, they have access to a wizard-driven setup GUI for setting whatever resources they need. It makes things a little bit easier to understand. It's still difficult to visualize all the resources once they have them set up, right? If I have a DB connected to a cluster, connected to a cache, connected to some sort of, object storage bucket, right? We still won't be able to see that whole interconnection, but it's going to be easier for us to set it up and know what's out there, right? And this access, this console access, right? Once you give this out, it becomes extremely difficult to take this privilege back away from the devs. All right. And this is how a lot of times we end up with organizations where, we had to do a cloud migration. Maybe in the original cloud, devs were not really doing too much on the cloud console, and things were being done through IAC, Terraform, or Ansible configurations, what have you. We moved to a target cloud, and then all hell breaks loose. We have to we have to basically give devs access because no one really knows this new system, right? And the issues that come out of this are we start getting unapproved changes, right? Folks are doing cowboy deployments through the console itself. We have no audit trail when things do change. There's no drift detection, so we don't even know what changed, right? And then, these three just are, go hand in hand with security breaches, okay? So the solution to this is defining IAC and ideally also baking in self-service before the migration even happens itself. Okay. So this does two things, right? The first is it's going to preemptively solve for bad design. When we're clicking through and setting up new cloud resources or networking or a new cloud anything, right? The click-through option, the click-through path, right? When we're doing it through the wizard in the console, very often we're just trying to, and I'm guilty of this myself, right? We're just trying to get the resource stood up, right? It starts asking for security groups and what I am rolled to assume. And it's like, okay, let me just pick this one. I think the other guys are using this too. And I just want my resource. I want my resource and I want it now, right? Like that becomes a driving factor for how we do things through the console. And this just inevitably leads to bad design. It could be unsecured. This could be, what I thought was a temporary testing Kubernetes sandbox that ended up getting turned into our QA environment, right? It could just evolve and grow into a lot of things without actually getting fixed, right? So setting up IAC, though, the process of that kind of preemptively solves for this bad design, right? When we set up IAC, we're going to be a little bit more careful about what configurations it actually gets loads with, right? It's very difficult to be sloppy when setting up IAC without realizing that you're being sloppy with it, okay? So setting up these IAC templates for the new cloud infra before beginning the migration is one of the key ways to kind of just have some sort of control over what's going out there. And once it does go out there, because everything is versioned and because you can see the exact configurations, right, it's easy to then go back and update or upgrade them when you see holes that need to be patched, right? Nothing's going to be perfect right out of the gates, okay? On top of this, right, we're also going to need a way to enforce some guardrails that can make sure that whatever our security posture is going to be met in this new cloud, right? Like very often in, say we're starting in AWS, right? We know our AWS workloads are compliant with SOC 2, PCI, and whatever else, security policies we have. All of a sudden we move to GCP and then it becomes the Wild West, right? And then security team spends a year and a half just trying to wrangle everything back under control, right? If we set up these proper guardrails preemptively before anything even shows up, right, this is going to save a lot of hassle and even just potential security breaches when we actually are starting to go live in the new cloud. Okay, and then the second thing, which is simplifying the developer experience, this is more to solve that day two problem of once we're actually using the cloud, right? If we have dev teams that started with console access, they're going to stay on console access, right? And really the only way that we can get them off of it is to give them a better alternative when it comes to their experience of setting things up, okay? Typically, this is going to look like a self-service infrastructure management / provisioning platform, okay? If devs need infra, give them a way to maybe even referencing those IAC templates that were created in this previous thing I just talked about. Give them the way to just one-click spin that up if they need to, okay? Give them access to these kind of templates if they just need to get up and going quickly, but also allow them the flexibility for setting up customized infrastructure if they need it, right? A lot of times we fall into, hey, do we, just leave things as the Wild West for the dev teams, or do we lock them down in the templates? And that's one or the other. We don't have to do one or the other, right? If we set up the right guardrails, we can say, here are some templates, right? If you want to use them just to go fast. But if you're a bit more of an advanced user or you know exactly what you want to do, I'll give you some flexibility to add some external resources like on top of this template that you need, okay? And doing this, right, we will be able to get away with just giving dev teams read-only access on the console when we're doing the migration. And a sign of a very good developer platform is if devs don't even really care to see this read-only access, right? That is the hallmark of like a really good internal platform for like that the devs can actually use. Okay. So with that said, they're coming up on time. The key takeaways here, guys, is that multi-cloud and just cross-cloud architectures, this is the future, right? Like I think gone are the days where folks are just going to be fully contained in one cloud. When we start moving into AI workloads and we start moving into just like heavier compute than just VMs and even Kubernetes, we're going to start noticing cost differences across different clouds and even just performance differences across different architectures. And that means that we have to use multiple cloud systems. Okay. And bad developer experience is going to lead to bad behavior, right? If you want a way to control cowboy deployments when we start going cross cloud and stop having the platform teams having to play bad cop and chasing down dev teams for what's going on in the cloud, right? We really have to solve for that, right? And frankly, the only way to solve that is bringing the right tools and systems, like specifically like platforms, internal dev platforms, for the job, right? If you bring the right tools, this process gets a lot less painful. Okay. So with that said, we here at StackGen have been spending, a year and a half actually solving this problem for some of our customers. And if you want more info on how do we actually solve for some of these things that we just talked about, go ahead and scan this QR code, and it'll take you to our website. You can sign up for an instance on our product, and we're also happy to meet. So at this point, happy to take questions, y'all.
Amazing. Thank you so much, Arnav. Thank you so much, Arshad. And just to remind everyone, since I want this session to be very, very interactive, I want a battle of the best questions. In the end, StackGen is going to choose the best question. And to that person who asked the best question, we're going to give away the free ticket to PlatformCon Live Day. PlatformCon, aka the biggest platform engineering event that is going to happen in June this year, 2025. We're going to have 2 live days, one in London and one in New York. And one of you has a lucky chance to win one of those tickets tonight. So with that, just to set the stage, let's get to the questions. And let me open it up here. So the first question, can you please share some light on migrating stateful resources?
Yeah, so migrating stateful resources is going to be like one of the hardest use cases. There's no real simple answer for this, and stateful resources is like it's an all-encompassing term, right? We can have stateful resources that are living within VMs, clusters, different compute platforms. There might be like proprietary compute platforms, where this all lives. And frankly, for stateful resources, I think the more difficult part than just the infrastructure migration is going to be the data layer on top of that and how to migrate that, right? So the key to a good stateful migration is going to be figuring out if you can set up a continuous replication on whatever on whatever data store that resource is reliant on. And that might even take some refactoring work just to allow it to be migrated. And also just depends on your, I guess, tolerance for downtime for that resource. So yeah, stateful resources, there's no easy answer for that. You're going to have to either sit with some downtime or spend a lot of time and energy making it a seamless cutover. Okay. I see another question from Tan. How does your solution ensure seamless interoperability between cloud providers, minimize? Oh, wow. Okay. seamless interoperability, minimize downtime, and minimize costs between cloud providers during a migration, right? And then long term, we also have to enforce security policies and compliance frameworks. Beautiful. All right, this is a great question. So, this is probably another 30 minutes worth of discussion, but in a nutshell, what Staction does is Staction provides out of the box generated IAC modules that can be migrated from cloud to cloud. Okay, so if you guys are using if you guys need to spin something up in GCP and you have nothing, for example, right? This is an example. In this situation, right, Staction can just auto-generate the IAC for you and just get you up and running. And we can set preemptive guardrails and security policies, like, for example, GDPR, HIPAA, SOC 2, PCI DSS. We can set those frameworks to be enforced so that all of the IAC that Staction outputs for you is preemptively going to be compliant with it, right? Because the last thing that we want to do is waste a week writing IAC. After that, try to apply it, try to do the plan and apply it, but then realize when we actually get to the apply stage that the security scanner is now throwing a whole bunch of security alerts and misconfigurations on it, and then spend another half week to a week to refactor it, right? Like that's one of the big wins that we offer for our customers, is just getting rid of that cycle. And then also, if you have your own existing either Terraform, or even if you don't have your own Terraform, right? What Staction does is Staction can synthesize Terraform IAC in whatever destination cloud you are trying to move into, right? And this goes back into that whole thing I talked about, hey, which DBs do you migrate to? Like, there's always going to be choices involved, right? And with Staction, what we can do is we can figure out how do we want to handle migrating different resources, and what kind of rules can we set up for those resources, right? So much longer conversation to be had around this, and like deep dive into our platform, but I hope I answered this at a high level.
Nice. Thank you. There's the next question. How do you migrate all your infrastructure as code Terraform, including guardrails?
Very carefully. This is something that I think in the past has been difficult, because frankly, there's you have to hand roll new Terraform when you do a cloud migration. That's one of the things that we're looking to solve. We don't want folks to be hand rolling anything, but we still want them to be using IAC, right? Because IAC comes with a lot of benefits, with like drift detection, audit trails, disaster recovery, etc. Stackgen, part of Stackgen's secret sauce is Stackgen will just synthesize new IAC for whatever that destination cloud you want to go to, and we can even keep those similar guardrails around security enforcements that need to get applied regardless of which cloud we're in.
Nice. How can transfer streaming process? Is this the full question? Probably.
I have no idea.
Probably doesn't make sense.
Yeah, so streaming process, I'm assuming this is something to do with like database replication, in which case make sure the target DB is running the same, target DB service is running the same like DB engine as a source, and then you should be able to set up a continuous sync like replication job. Assuming that's what you mean by streaming, I think that would be the answer, but I would probably need some more context.
Yeah, if you want, I don't even know how to pronounce this name, but Sheen, if you want to clarify, feel free to drop in the chat and we'll get back to this question. What advice do you have for someone considering becoming an independent consultant specializing in cloud migration?
That's a tough one. Arsha, do you have any insights on this one?
I think, the answer would be, there are so many different avenues you can start with, right? But understanding at least deeply and very well two cloud environments, two other cloud providers, and what does it take to migrate across the two would be a good starting point. But it's a very involved space, takes a lot of time. We've been at this for a couple of years, so with a fairly good sized team. But just starting with two cloud service providers, understanding the resource mapping, understanding what it takes. Pick one area, either at the infrastructure layer or the application layer or the data layer. Pick one of these three, and then start building your capabilities. That would be a great place to start, Stephen.
Perfect. How do you evaluate and select the right migration tools for different phases of a cloud migration strategy, and what factors influence their effectiveness in minimizing downtime and ensuring data integrity?
Yeah, so I think there's two parts of this question. The first part is for the tool evaluation, right? In general, the tool evaluation has to be centered around how much time and effort am I saving the dev teams or platform teams and DevOps teams that are actually involved in the migration, right? Whichever tool can save the most time and requires the minimum amount of setup, and or whichever tool can help me shift left that responsibility onto dev teams to help decentralize the I guess effort / responsibility for migrating is going to be the best tool. Okay. Now, factors around minimizing downtime and making sure that we have data integrity. This is sometimes a tooling issue, an issue that we're going to use tools to solve this, but this is more of a human problem in my opinion, right? Minimizing downtime is I don't think there's a tool out there that's going to just magically minimize downtime for you, right? You're going to have to figure out a migration strategy on an application by application basis, and figure out how much downtime, if any, is acceptable when we do this migration, right? There's a lot of internal services where if it goes down for an hour or even half a day, no one's going to care, and maybe one person will notice, and it's not going to affect the business, right? Meanwhile, there's going to be customer facing production services where absolutely we cannot suffer more than 1 minute of downtime, if even that, right? That frankly just boils down into data replication and then network cutover once we've already set up our CI/CD. So this becomes a more human issue to solve. Just make sure that you're using the most modernized tools for the job in each of those areas.
Yeah, totally. As cloud environments grow, government policies often lag behind. How can we design a self-healing governance framework that adapts to dynamic cloud changes without human intervention?
Ooh, I like this. So this question is something that a lot of the teams that we work with, that they suffer through, right? Security teams are always playing whack-a-mole, trying to plug holes and enforce new security standards or updated security standards within their cloud environment. And this is where a lot of CSPM solutions actually help try to solve. But when it comes to self-healing governance framework, really what that means is, hey, I have some infrastructure that a dev team provisioned 2 years ago, and they're still using it. At the time, 2 years ago, when we provisioned it, this thing passed all the security scans with flying colors, right? But since then, since we haven't redeployed this infra, this has not really been rescanned, possibly, and this is not, or maybe it hasn't rescanned, and we know that there is an issue. We just have to fix it, right? This typically requires human intervention to solve, right? In the future, I think the best systems are going to be able to detect what changes would need to be made to that infra in order to make it compliant. Secondarily, detect if that change can be made without resulting in a delete and recreate operation on that infrastructure. And if the answer to that question is yes, it should be able to automatically make that reconfiguration without dev teams even knowing about it, right? This is probably the holy grail of just automatic self-healing governance when it comes to cloud infra.
Nice. Have you come up with best practices, recommendations for cloud-to-cloud migrations from your experience with cloud-to-cloud migrations, which you could share? For example, for migration resource A to in AWS to resource B in GCP, This is the recommendation. This would help reduce migration pain for some others.
This is a good question, and the answer is definitely out there. I don't know it for every migration scenario, but there are people who do know this, right? And they're typically going to be on the solution architecture teams, working with, say, these public cloud hyperscalers. They typically see these type of migration scenarios and all sorts of different scenarios, and like I think they would probably be the best ones to actually have this. So the data is out there. I unfortunately don't have it.
Cool. I see you guys doubling the questions in the chat and Q&A. Q&A is fine. So usually
I see it. I see it. Actually, the last question from Jose is interesting too.
Yeah.
What's the strongest services in AWS and Google Cloud, and where would you put your Kubernetes production cluster? So for me, hands down, I'm putting anything Kubernetes inside Google. This is a personal opinion. I think Google's implementation of GKE just far surpasses the other cloud vendors. And in terms of ease of use, right? Like this is something where I like they've really done a great job with the user experience and the management experience for the clusters, the automatic upgrades, like the node pool upgrades, like just managing it becomes almost an afterthought because of how simplified they've made it. And frankly, I think some of the cluster setup and some of the cluster access, like if you have to have dev teams doing cowboy deployments with console access, GCP actually makes that easier, and that's something that experience is quite difficult to do, but I think they've pulled it off. So for Kubernetes, my personal pick, hands down, would be GKE.
Nice. We still have one more minute. Are you on, do you need to jump right now, or can you stay in our show?
No, I can stay. Let's
We can stay for a couple of more minutes, but let's finish this 2-3 questions that we have. I mean, I just want to respond to Mohammed Danish, if that's okay, Maria. I mean, his question is fine. It's a good question. Look, we do believe that the cloud migration space is going to get more and more seamless and automated, but I think we are a little bit far away from it being completely fully automated, or the manual thing is going to be obsolete. I think there will always be a human in the loop for many different reasons, for quality reasons, auditability reasons, risk prevention reasons. So there will always be a human in the loop. Today, we are able to automate about 80% plus, going from one cloud to the other. But I think that number is only going up, but I don't think we're going to be 100%, because by design, the cloud service providers want to be proprietary so that they can lock you in and they can keep you in as much as possible. That's how they make their money, and they'll keep throwing new things at you, or different ways of implementing certain things which are different in different clouds. But definitely, it has become much more simpler, is what I would say. I don't know if you want to take the question from Lothar, if I'm pronouncing it right. I think it's an interesting.
Yeah, let me read it out. In the meantime, is there a possibility, some sort of, let's call it red alert list of more proprietary cloud services that when used in a solution, you would advise better not to migrate at all when possible? Or are there possibly patterns of implemented business logic that might be too spread over different subservices?
Right now, I can say such a list probably does not really exist, right? Like this list really has to be derived internally, because even for some of the application architectures that I defined earlier, where I talked about them as if they're on a red alert list, right? There's different way, I didn't get too far in the weeds on that, right? There's some nuances about how, like, what kind of data the application works with, and like what kind of query system that we're actually using, that can make something that is a red alert for one organization, like not even a problem for another engineering team somewhere else, right? So this is something that I think as this cloud migration space evolves, like we're going to start figuring out what are these high level red alert categories, like the one that I brought up. Yeah, I think, I mean, honestly, I think this would be a great project to work on.
Nice. And the drum roll. So you guys, what was the best question? The one that you remember, I guess.
I think, I don't know, my vote goes to Tan Sai. Which one are you picking?
So the second one, how does your solution ensure seamless interoperability between cloud providers?
You know, that is a pretty good one. I just, yeah, you know what, when that question came up, I was already thinking, hey, I really like the thought that went into this. I just want to give it a shout out to the runner-up, which Mohammed, the question around the self-healing governance framework, that one really captured my heart. I think I think that one's like a question that we can all kind of take away from it and kind of, you know, sit with us and chew on for a bit. So I love both of those, but I agree with your choice on 10.
So Arshad, you have a final word. Which one then do we give it to?
Can we just send out 2 tickets, please?
You guys.
Leave it to you, Maria. You pick.
Okay. No, we can totally have 2 tickets. So Muhammad and Tansai, I'm gonna contact you after this webinar, so that you can redeem your tickets, and hopefully we'll see you in person at PlatformCon. Are you gonna be at PlatformCon, by the way, Arshad, or no?
Yes, we will be at PlatformCon. Yep.
Amazing. So you'll get to meet these 2 in person. And yeah, if you have any other questions about cloud migration, that's the way you can hunt them down there. But I would like to thank Arshad and Arna for this session. It was truly insightful. It's great that we're still online, right? Like after 1 hour, people still want to stay on, and it really moves the needle. Also, just to remind everyone, we're going to send out the recording and slides to everyone who joined, to everyone who registered, and you can share this presentation with your colleagues or just rewatch it whenever you want. Also, we host these sessions within the platform engineering community every week. So if you want to check out our schedule, it's platformengineering.org. It's out there in events, or just join Slack. Like I'm sure if you are in the platform engineering, you're building a platform, you're looking into all the things, you know, platform, that's a space to be. And thank you so much to our attendees who stayed with us either
Yeah,
this
quick word on
early
that, by the way.
morning.
If you're interested, I love talking about this stuff. You can find me on LinkedIn. My name is Arunav. You just look up StackGen. You know, would love to connect and chat more. You know, this has kind of been a one-sided presentation for the most part, and yeah, I love talking about this. So looking forward to future conversations.
Totally. Or hit them on Platform Engineering Slack. I'm sure that you guys are there with more questions. But with that, thank you so much, and I hope everyone has an amazing end of the day. Cheers.
Hey, everyone. Have a great day. Bye.
Take care.